Okay, after I think we did this one. Okay, so we're gonna move on to 17. I don't think we've done 17.
These are numbers. Oh, do I not? Oh, wait, I'm on the wrong one. I think.
Do you guys all see where we're at? 17. Jonathan pushes the 3 kilogram box named Carl. Everybody at the same point? Okay, so we're applying kind of what we talked about in the lab. Jonathan pushes a 3 kilogram box, Carl, out of the ditch. He pushes it up a smooth, frictionless, which is kind of nice, frictionless inclined plane of 30 degrees. Okay, 30 degrees. With a applied force of 40 newtons. So the applied force applied, is 40 newtons. All right? Yes?
If the inclined plane is frictionless, then how does Jonathan have traction to push it?
Because his back foot is still on the ground, obviously.
It's a long leg.
Doesn't say the length.
Measure the
There's his foot.
Plane could be like.
It can work. It can work. He's just like pushing, right?
Yeah.
Question about the problem?
Yeah. Wouldn't it be better problem design to make it so that he puts a rocket engine on it instead?
Maybe.
Because you see, if you
No, I didn't mean to ask.
All right. So, number 1 says draw a free body diagram. So we know force applied. What other force do we know? Gravity, straight down. Of course. What's the other one?
Whatever. Normal.
Normal force. Would that be straight up? Ah, almost got you. You guys came ready. Normal force would actually be like that. Right? It's whatever's perpendicular to the slope. Does that make sense?
Yeah.
Okay. So, in other words, I'm going to draw this. I don't like to think on a slope. I'm going to draw it flat because I like flat surfaces, and I think flat surfaces are easy to picture. So, I got a box. All right. My applied force is still going up. Oh, force applied. All right. My normal force now is straight up. Well, that's nice. Now, gravity. Gravity is actually going to be, so my normal force, gravity is going to be going to the left. Right? That's the force of gravity. This is the opposite of my normal force. Okay? And this angle right here is going to be this angle right here. So right here is 30 degrees. Does that make sense? Yeah. So the angle here is the same angle there. And that's what we know. That's what we know. Okay? So it says find the normal force. Find the normal force. All right? Let's see. Well, this was 40. Okay? Okay. So, in order to do this, the normal force is the same thing as the force below it, right? Okay? So, I need to solve for my y direction. I don't know my x. I'm solving for y. Is there a way I can solve for gravity? The force. So force is equal to mass times acceleration. Well, I know the acceleration due to gravity is 9.8. What's the mass? In this, we're going to use positive.
Okay.
Since we're pushing up. So mass is 3. What is those two combined? 29.4 newtons. So this hypotenuse is 29.4 newtons. Okay. Is there a way I can solve for y? Okay. I'm going to solve for y. So katoa. So cosine is correct. So the cosine. So katoa. Jason? over 29.4. What's our y end up to be? 30?
25.5. 25.5. Yeah.
Oh. I'd have to agree. 25.5. Sig figs is a little tricky because the cosine of 30 is probably irrational. So we would theoretically, I guess, use 3 sig figs.
Cosine of 30 would be square root of 3 over 6.
Is that irrational?
Yeah. Wait. So the reason why the normal force is 25.5 because it's perpendicular, so that y is the force normal.
Yes.
Goes all the way up.
Exactly.
Okay.
So this below will always equal force normal. Always.
Also, how do we get y? Okay, so I'm just having a brain fart right now.
Right?
How do we get y equal cosine? Like, how do we do that? So do we just
So Katoa.
yeah, I know the cosine. So do you just do the cosine and negative 1? I'm so lost.
So-
Cosine of 30 times 20.
You take the cosine of your angle is equal to the adjacent
Yeah.
over your hypotenuse.
So you just multiply cosine of 30 times 29.4.
Yes.
Okay, I was so lost on why.
Yeah,
I didn't
You would
understand.
multiply 29.4 on both sides.
Okay. I don't know why I didn't think about that.
Okay. Now, next, find the acceleration of the block. Okay, find the acceleration. Okay, well, we'll have to actually solve for our x direction here. Okay, so what's our x direction? How can we solve for that? Sine, okay, sine of 30. Sine of 30 is equal to the opposite over the hypotenuse. Okay. What's x end up to be? Say that one more time. 14.6.
I'm not agreeing.
14.6, 14.7. We're pretty close. All right, so that's our x direction. Now, find the acceleration.
I did it with acceleration.
All right. So, in order, we need to find the force is equal to the mass times the acceleration. Now, there is actually 2 forces acting on us in the x direction. There's 2 forces. One of the force is the force applied. I'm pushing it up. That's 40. However, there's a force due to gravity that's pushing me back. So pushing me backwards, I'm going left, right? 14.7. So I'm going to subtract that. Does that make sense? Gravity's kind of fighting against me, pushing it up a ramp.
So why do we subtract 14.7?
Because gravity's pushing against me while I'm going up the ramp. Okay? I'm going left. We have my hypotenuse. All right? So that's why it's a subtraction. Yes?
Well, it'd have to be going against you because gravity is helping you push it up the ramp. You have a serious problem.
That would be serious, yeah. It'd be interesting,
It
that's
also
for
won't
sure.
stay on the ramp.
And that is equal to the mass. My mass is 3 times A. Okay? So if you subtract those 2 numbers, divide by 3. 8.4. 1 sig fig. 8. Does that make sense?
This is the most it's made sense in a hot minute.
Say what?
This is the most it's made sense in a hot minute.
That's fantastic.
I
That's
just don't
fantastic.
understand,
never mind.
So why would, okay, I understand why, I just know that if I had to do this on my own, I wouldn't remember to subtract the x.
That's
When
fair.
you
You got
explain it,
you
it
do
makes
got to
it-
consider all your forces in
When
that
I-
direction.
yeah, and I wouldn't think, I would just think, okay, so I would just subtract either the force of gravity or something, just because that's what I thought. I
That's-
wouldn't think to subtract 14 times 7.
That's fair. That's fair. Let's try one more. Let's try one more.
Just draw.
Oh, yeah.
Yeah, why are they beating up Carl?
They're fighting over Carl. They're not beating him up.
Oh, okay.
They're pushing
I thought
into
those
him,
were like.
though.
Okay.
You heard what I said.
Let's erase all this.
You sure they're not weird?
All right. So let's see.
Yeah.
Once the box Carl reaches the top of the hill, so Tonathan pushed him to the top. Tonathan and Billy began fighting over it. The 6 kilogram box. Uh-oh. He gained some weight going up the hill. The 6 kilogram box is acted on by the two forces F1 and F2 as shown in the diagram. If the magnitude of F1 is 13 newtons at 60-degree angle, we already got that. And F2,
Is Carl actually just a child inside the box?
no, you'll see.
Is Carl
Gotta
a
wait for the
box full
story
of
to
ice?
unfold.
Mr. Bowers,
Another question about the story.
is Carl a box of ice? Because in the packet it says the acceleration of the ice.
Is he just a block of ice, man?
Is that why he gained so much weight?
Where are we at? What question? Oh, we're on 19. We skipped one.
I get it's a typo, but I don't know what ice came from.
I don't know. I don't know.
It's not for
Yeah.
Yeah, wait.
These are different questions than what we have. Like, it's the same scenario, it's just different questions.
Mine? I skipped 18 on mine.
Yeah, we skipped 18.
We skipped 18.
19 on the back.
We're on 19.
Our questions are all.
Yeah, but like,
Acceleration of ice.
yeah.
I guess we can't do it because there's no ice.
A says
Oh.
A on our paper says the acceleration of the ice. B says the normal force exerted on the table.
Where's the table?
Well, that's just silly.
So I mean,
Same concept. Okay, so what is the acceleration of the ice? All right, so all we're worried about is the x direction. So we have to answer all our x values. Okay, got to answer all our x values. So how can we solve for this x? Well, I guess he's actually pushing this way. What's that x? How can we solve for x?
cosine.
So cosine is correct. So someone solve for this cosine. Someone solve for this cosine. Yes.
The second one is 9.526.
9.526.
The first one is 6.5.
6.5. Does that make sense? We good on that? So what is the acceleration? Okay. So same equation. We got to solve the sum of forces is equal to the mass times acceleration. Okay, so what all forces do we have? Well, we have one force pushing to the right. Right is positive, right? Right is positive, 6.5. So we have 6.5. We have one pushing backwards, 9.526.
So
Minus. That's a good catch. 9.526. Did it tell us mass? Yes, it did.
6 kilograms.
Mass is 6. So how would we solve for acceleration? Well, you subtract and divide 6 over. So what our answer be in one significant figure? Negative 0.5.
Yep. Now this one made sense.
Yeah.
Okay. All right. Let's keep this pace.
Let's keep this pace.
Not too fast. Not too slow.
Not too fast. All right. So let's see. Find the normal force exerted on it on the table. Okay, so now we're worried about all the y directions. All right. Can I erase this? Yes. Oh.
So, every up in the test or quiz, will we be given a visual? Because like, how would we, like, what if?
Oh,
we
yeah.
reverse the-
So you'll give us visuals.
Most likely. If not, I will be very detailed in what I'm saying. Yes,
Is
sir.
our test on this gonna be Monday or Tuesday next week?
We'll see how tomorrow goes.
No. Let's not do it before break. Let's
Well-
save it for after. Let's procrastinate.
We'll see how it goes.
Wait, I thought that was.
Now that I say that, yeah, we might want to do it Monday
Okay.
or Tuesday.
Got it.
So let's see. What is the normal force exerted on the table? All right, so I'm going to have my sum of forces in the y direction. Oh boy, all my forces in the y direction. What is all affecting the y?
Gravity.
All right, so I got gravity's pulling down. Okay, so I'm gonna put that at the end.
The normal force.
Okay, the normal force is going up, so that's what I'm solving for. I'm gonna put that first. What else is affecting the force in the y?
They're pushing everything down.
The Y direction and our.
They're both pushing down.
Okay,
So
did I subtract them or? Yeah, you're exactly right. So they're pushing down. So minus F1 minus F2 in the y direction.
oh, so you wouldn't even have to figure anything out because wait. So for F1 and F2, would you use sine to find the
Exactly.
Okay. I didn't know if you would use a hypotenuse at all.
I mean, you can use a squared plus b squared equals c squared.
I meant like just the hypotenuse in F1.
Oh, no. I see what you're saying.
Yeah.
Absolutely. Question?
Are they actually fighting over, or are they trying to push each other down the hill?
Well, they're kind of fighting over it. They're kind of smushing Carl,
It's over.
which is not that nice. So, if you look at sine of 60, did anybody solve for y here? Or I guess it should be down, my bad. 11? 11.26, so that's F1. Did anybody solve for F2 over here? 5.5. Does that make sense how we're getting those numbers?
Yes.
Okay. Force of gravity, so that's going to be mass times acceleration. So the mass is 6 times 9.8, because that's acceleration. 6 times 9.8.
Would it be negative? Since it's going in the negative y direction?
Well, we're
Oh,
subtracting.
we're already
it.
subtracting. I get it. Okay.
So all my forces is equal to the mass, which is 6. Oh. Times. Now, this is where it's a little tricky. Since it's not, we already calculated the force of gravity over here. Now, we're just looking at the force of the box. Is it moving in the y direction? No. So the acceleration in the y direction of the box itself is 0, since it's not moving in the y direction. It's just staying put, right? They're pushing down on it, but it's not moving down. Does that make sense? It's like me pushing down on this. I tried. I really did. Okay. So all you got to do is, well, that's 0. add all those numbers to the other side.
75.26. Okay, so no, it would be 75.3 for 6
75.3.
It's like 75 over 6. So with 6 pigs, we get that 76. Wait, what?
Yeah,
75.6.
It's gonna be 76 because it's
11, yeah, so.
Well, no, because we don't do the 6 until the end. We're focusing on-
75.6 because.
It would be.
subtracting, so it's the number of decimals.
Yeah, but
Yeah.
11.26 might just be.
Still one decimal.
Might just be the biggest number.
Okay.
Yeah, but we don't do that until the very end.
So does that make sense? You just add up all your forces. So it's very, very important to analyze all the forces. How do we feel on slopes?
I actually feel a bit better today.
I feel better.
All right, tomorrow we're gonna look at some friction.
Sweet.
Friction's the easiest part of this chapter.
You are lying. We cannot trust. Look
You
what
guys
did
don't
to
trust
us.
me?
You.
After the water.
After the
I-
water bottle
hey.
comes downhill from there.